Here we are in section 2.2, exercises part C, with the solutions for numbers 10 through 21. Here we're going to be using a lot of formulas, so we should be sure and know where to find them in our textbook, and we'll look at them really quick right now. In section 2.2, here's a temperature conversion formula and the shapes, so we'll be grabbing them from here and you can follow along in your textbook when we use them. Let's start number 10. Use the formula for temperature conversion to calculate the temperatures in degrees Celsius. So we're going to use the formula, which is C equals 5/9 F minus 32. And this can be found in your textbook. So for this one, -20 will go in there, and we will have C equals 5/9 -20 minus 32. That's going to be 5/9 times -20 minus 32 is -52. Let's punch that in our calculator and see what we get here. 5 divided by 9, that's 5/9, times 52 with a negative on it equals -28.9 degrees. So that's going to be a -28.9 degrees. Let's check our answer. There's number 10, -28.9 degrees Celsius. And we should make sure that our answers are in complete units. So let's put that C right on there. Okay, number 11. F is 59 degrees. So the Fahrenheit is 59. So it's going to be Celsius equals 5/9 of 59 degrees minus 32. And we get 5/9 times 27 is what it looks like, 27 degrees. If we take 5/9 times 27, we get 5 divided by 9 times 27 equals, and we get, oh, it comes out nice and even, 15 degrees Celsius. That's what we have. And let's make sure and double check that answer. Yes, 15 degrees Celsius. The next one, number 12. Here we have F is 32 degrees. 32 degrees is freezing, so we know that that's going to come out to be 0, but let's watch it happen in the formula. C is 5/9 of 32 minus 32. 32 minus 32 is 0, so we get 5/9 of 0 times 0, and we do indeed get 0. So the answer would be 0 degrees Celsius. There we go. Good. Number 13. Now the formula for cylinders we'll have to get out of the textbook. So we get volume equals pi r squared h. That comes out of section 2.2, and if you need to look back into the instruction to find that, you'll need that for these problems. Once we have the formula, we can stick in the numbers. 6 goes right in there into R, and 12 goes into H. So we get volume equals pi times 6 squared times 12. Oh, that's nice. If we plug this into our calculator, 6 squared, we know that is 36. So we're going to get 36 times 12. That equals 432. So we have 432 times pi, and we can see what that is on a calculator. 432 times pi equals 1357.2. 1357.2. Now notice that we were given inches at the very beginning, and we're looking for volume, which is a third dimensional object. So this is in inches to the third power, inches cubed. Now you may write the answers as 432 times pi, or rounded to a decimal place, and that's okay. Either one of those is all right. Let's check our answer. And there we have 1357. Oh, they rounded to 2 decimal places, or they did 432 pi. And notice the units are inches cubed like we have. Excellent. The next one, number 14. This one is not looking for volume, it's looking for surface area. And that formula is surface area equals 2 pi RH plus 2 pi r squared. And you can get that out of your textbook there. So we're going to stick 9 in everywhere there is an r, and 5 in wherever there's an h. So we get that SA is going to be 2 times pi times r, which is 9, times 5, plus 2 times pi times 9 squared. So this is going to equal 2 times 9 times 5, that's 90 pi, plus this is 9 times 9 is 81 times 2 is 162 pi. So adding those together, and we get 252 pi. Now let's plug that in and get a decimal out of that. Make sure we know what it is. 252 times pi equals 791.68. 791.68. So you can have either of those answers, but in either case you need to make sure that the units that you're using, notice we were given meters for these lengths. We're asked for an area, which is a two-dimensional object, so these are meters squared. And your answer can be written with the pi still on it, or it can be written with the decimal. Let's double check our answer. There's 791.68 meters squared, or 252 pi meters squared. Good. The last one for cylinder is LSA. Let's write that formula up here. And we get LSA that's just 2 pi RH. And that means lateral surface area, or surface area just on the lateral sides, on the vertical sides. So this equals 2 times pi times r, which is 3, times h, which is 8. So 2 times 3 is 6, times 8 is 48 times pi. So you may leave it as 48 pi or stick it into a calculator as 48 times pi equals, and you get 150.796. Ooh, if we round it to two decimal places, that's 80. So 150.8, 150.8. And what kind of units do we have here? We were given these lengths in yards, but we're looking for an area, which is second dimension, so yards squared. Notice we can plug the numbers in here and then make sure we have the units by looking back. So let's double check our answer. And we get, yes, 150.8 yards squared, or you can leave it in the exact non-decimal representation of 48 pi yards squared. Great. Ooh, next one, we've got a triangle to calculate this next time. So let's look at the formula. What was the formula for A in a triangle? Well, area is 1/2 base times height. And we have B is 6 and H is 5. So let's stick those in, and we get area equals 1/2 base times height. So 1/2 times 6 is 3 times 5 is 15. So 15. Now notice that our units were in feet, and we're trying to find an area, which is in the second dimension, so we will have feet squared. 15 feet squared. Let's double check our answer. Yes, 15 feet squared. Next one. Ooh, we get to use that exact same formula. Area equals 1/2 base times height. Let's write out what we have. Area equals 1/2 times 15 times 4. 1/2 base times height. 1/2 times 15 times 4. It'll be a little easier to do 1/2 times 4, which is 2 times 15 is 30. And again, our units are going to be second dimensional because we are area. Centimeters squared. Let's double check our answer. Yes, 30 centimeters squared. The next one, in a triangle, it's talking about angles. And if we look in the textbook, they have to add up to 180. I think the formula looks like A plus B plus C equals 180. Okay, so what are 45 plus 79 right now? 45 plus 79 is 124. So we would need to take 180 minus 124 gives us 56 degrees. Good. Let's double check that answer. 56 degrees. Number 19. Use the formulas for a trapezoid to calculate the missing value. Now in a trapezoid, the area is 1/2 big base plus the small base times the height. And they may have height over here, 1/2 height times this. So let's see what we get. If we take the little b as 9, the big B as 11, and the h is 7, we get 1/2 11 plus 9 times 7. So what's 11 plus 9 is 20. So 1/2 times 20 is 10 times 7 equals 70. Now let's look for our units. Kilometers are the lengths, but we are looking for area, which is a second dimensional object, so this will be in kilometers squared, square kilometers. Let's double check that answer. 70 kilometers squared is correct. Number 20, we have the same formula because we're looking for area here. So area will equal 1/2 the big B plus the little b times the h, which is 5. So we get 1/2 times 23 times 5. Oh, we're going to start getting some decimals here, so I'm going to pull out my calculator and use this. 1/2, which is 0.5, times 23 times 5. And we get 57.5. 57.5. And what are our units? Here we have millimeters for these lengths, and we're looking for area, so that means it's a second dimensional. We're in meters squared to get a good area unit. So let's look at our, we could have kept it as a fraction, 115 over 2. That would have been fine, or 57.5 like we did. And the final one, number 21. Same formula in a trapezoid? No, we're looking for perimeter now. Now perimeter was just adding up all the sides, which were, they had a shape and it was, perimeter was all of them added up together. The base on the bottom plus the side plus the base on the top plus the other diagonal side, and they may have had them in different orders, so we're just going to add them up. So we get that the perimeter is going to be 12 feet plus 25 feet plus 13 feet plus 17 feet, which adds up to 17 plus 30. 17 plus 13 is 30, plus 25 is 55, plus 12 is 67. Now, what kind of units do we have? We have feet as the inputs, and we look to see the perimeter. The perimeter is a length around there, so the answer will stay in feet. A little word about units after we check this. Yes, 67 feet. These units actually come together in, you'll notice here we added feet and they were all the same thing, so we ended up with feet. Here we added two things that had millimeters and then we times by a millimeter. So that was millimeters times millimeters, and we get millimeters squared. Same thing here. We had kilometers plus kilometers. We times by kilometers and it gave us kilometers to the second power. And yes, number 20 did indeed have millimeters squared on it.